So we are now ready for a major segue in 802. This is the moment when we introduce magnetic fields. 802 is about electricity and magnetism, and we're now ready to start talking about magnetic fields. Why? Well, the first step towards magnetic fields that we took was the moment when we started to allow charges to move, when we started to allow currents to flow. We've been talking about currents in wires. We've been talking about conductivity, resistivity, understanding how conductivity is related to microscopic properties of a material, understanding Ohm's law. Another basic feature of what happens anytime you have electrons flowing through a wire, so anytime you have a current, is that currents make magnetic fields. So the moment we let our charges start to move, although we didn't stress it until right now, we started to allow them to make magnetic fields as well as electric fields. So that's where we're going. A few lecture segments down the road, we will show in quantitative terms how it is that a current makes a magnetic field. But before we get there, first of all, we're going to do a little bit of an introduction to magnetic fields. And then, just as the way we started out with electric fields was to ask, suppose I have an electric field, what does it do to a charge? Remember, we said, well, if I have a charge here and there's an electric field pointing that way, then the charge field is a force. Now we're going to ask the same question. If I'm a charge here and I'm in a magnetic field, what happens? So we're going to do an introduction first. That's this segment. And then we'll do some demonstrations, part of the introduction. Then we're going to ask, what do magnetic fields do to charges? And then we'll circle back and show and discuss in quantitative terms this basic fact of nature, which is that anytime you have moving charges, they make magnetic fields. So, but what's a magnetic field? You're actually very familiar with magnetic fields. You're familiar with magnetic fields from childhood with maybe magnets on a refrigerator, from high school. The most familiar magnetic field is the one that's produced by the Earth. So here's the planet Earth. And the Earth is actually a giant bar magnet. And paradoxically, the way our notation works, it is in fact true that the north pole of the Earth is a south pole of the bar magnet, and the south pole of the Earth is a north pole of the giant bar magnet. Why is this? Well, what do we mean by north and south pole? You know from childhood that north poles attract south poles, and south poles attract north poles, and north repels north, and south repels south. And in particular, the way we define what we mean by north and south is we take a compass, and if I'm here on the Earth and I have a little compass needle, or I'm here on the Earth and I have a little compass needle, or I'm here on the Earth and I have a little compass needle, I'm here on, actually that's not drawn correctly. If I'm here on the Earth and I have a little compass needle, we define the direction of magnetic fields by saying that the north pole of the compass needle points in the direction of the magnetic field lines. And the north pole of the compass needle is going to be attracted towards the south pole of the Earth. So what that means is that each of these little compass needles has a north pole and a south pole, a north pole and a south pole. And the south pole of this compass needle is being attracted to the north pole of the Earth's giant bar magnet. The north pole of this compass needle is being attracted to the south pole of the Earth's giant bar magnet. So the Earth is a giant magnet. You've known that any time since the first time you saw a compass. And in fact, it is a giant magnet whose south pole is near the north pole of the Earth and whose north pole is near the south pole of the Earth. And I apologize for this. If you start thinking about it and try and set up a better notation, if we didn't have this problem, we would have a different notational problem. So there's really no way around having a notational problem of this type. So what we're going to do next is we're going to do a bunch of demonstrations to start to get get or remember our intuition for how magnets and magnetic fields behave. So I'll see you next in the lab.